In this video, I'm going to use implicit differentiation to write an equation of the tangent line to the graph of e to the xy minus 2x equals 0 at the point 1, ln 2. All right, so implicitly, remember, I'm solving for y prime or dy dx in order to find a function that's going to give me the slope at any point. And also, whenever I differentiate a y, I need to include a y prime with it. So I have an e to the xy, and I need to differentiate this. So I went over here and wrote the little differentiation rule for e to the u. Remember, it's u prime times e to the u, and that's our little chain rule. Okay, so what's this going to look like? Well, this xy is my u in this case, so I need to differentiate xy and put that out front. So it's going to be the product rule. So the derivative of the first, which is 1, times the second, plus the first times the derivative of the second. And the derivative of y is 1, but I have to include a y prime, so just like that. And then e to the xy. So this right here will be the derivative of the term e to the xy. And then the derivative of negative 2x is just negative 2, and that equals 0. So it looks like here I have the y prime just in one location, so I need to isolate that now. So we can do a couple of things here for the first step. Let's go ahead and add 2 to both sides, and then let's go ahead and distribute this through in an effort to start to get this y prime by itself. So I'll have y e to the xy plus, let's see, x e to the xy y prime equals 2. Okay, once again, here's this term we're trying to isolate. So let's go ahead and subtract this term from both sides. So I'll have x e to the xy times y prime equals 2 minus y e to the xy. And then let's go ahead and divide both sides by that coefficient over here. Okay, so that all cancels. And y prime then equals 2 minus y e to the xy over x e to the xy. Okay, so y prime is all by itself, so I know this expression on the right side is going to give me my slope that I need to write a tangent line equation. And the ordered pair I'm going to plug in is 1 ln 2, so the 1 is my x, the ln 2 is my y. So let's go ahead and plug that in and see what my slope is going to be. So 2 minus y, which is the ln of 2, times e to the xy. So it's 1 times the ln of 2, so we can keep it just like that. And then x, which is 1 times e to the xy. So once again, that's just the ln of 2. So now we just need to do a little bit of simplification. So it looks like 2 minus the ln of 2. And we have here in a couple places e to the ln of 2, e to the ln of 2. Well, the natural log and the e cancel out because they're inverses, and it leaves me with just a 2. So we'll do it here and here. Okay, so as I continue here, it looks like I can factor a 2 out of every term. So I'll have 1 minus the natural log of 2 over 2. Those 2's end up canceling, so it appears my slope is 1 minus the ln of 2. Okay, that's fantastic. I can combine that now with this ordered pair, 1 ln of 2, to go ahead and write now this tangent line equation in point-slope form. So I'm setting it up here. Here we go. This is what this point-slope form looks like. So let's say y minus the y-coordinate, which is the ln of 2, equals your slope, which is 1 minus the ln of 2, times the quantity x minus the x-coordinate, which is 1. So here's what this line will look like, this equation for the tangent line. And so when we look at the graph, here's what that looks like.